I'm very happy to be able to moderate and welcome Casey for our second keynote lecture for our ShenZhen Visiting School. If I may just introduce Casey. Casey is my colleague here at the SciArc in LA. Casey is a multidisciplinary designer and founding partner in Ishida Rehm Studio in Los Angeles, CA. He teaches at the Southern California Institute of Architecture, where he is coordinate for the Masters of Science in Architecture Technology post-professional program. He has professional experience working in offices in Los Angeles, New York, Berlin, and London on a range of projects from low-income residential to large cultural projects. Let's welcome Casey. Thank you for joining us.
Thanks for having me. Should I just start?
Yeah.
Oh, okay. Excuse me. I'm sorry, I'm a little under the weather. Let me share my screen here. Okay. So thank you very much for having me. Sumi said, can you guys see my screen okay?
Yeah.
The videos are not playing. Okay. As Sumi said, I have a very diverse practice, but the entire practice really hinges around kind of an obsession I've had since about 2003 on dealing with intelligent agents, different forms of artificial intelligence, and designing software that helps me to design. So I put this up as just a kind of example. This app really sums up a lot of things. This is a autonomous robot 3D printing kind of platform that I wrote at one point, which uses a combination of like laser scanners and web cameras, and various kind of AI algorithms, as well as some like simple intelligent agent-based scripts to create autonomous like architectural production or design production. So there's no like preset design before the robot runs. It basically, puts down a little bit of plastic, pulls back, rescans it, and then kind of updates its design decision making to put down additional layers of PLA in this case. And this whole idea about building machines which are kind of responding to things outside of themselves raises a lot of issues as a designer. Sorry. And like one of those things is like, how do you design software that is robust or capable of basically engaging with information that's sometimes noisy or banal or uninteresting? And how do you generate like content which is both somehow embodying an authorship or an aesthetic that you intend to design into your apparatuses, but has the flexibility to engage or transform incoming information into something productive. So another project I worked on recently that's along those lines is an exhibition that I worked on last fall at the Frac Museum in Orléans, France. It's basically a piece of software that we created that the idea was to create a media piece that would evolve over 3 months, learning from architectural information on social media. And some of the kind of phenomena that I'm interested in within these kinds of contexts are brought up by Lev Manovich in his essay or his research project into Instagram and some of the emerging aesthetics there. So when you're working with kind of information from outside of yourself, or like when you're mining things from the internet or social media or even a LiDAR scanner, it's interesting to start to look at what are the kind of phenomena embedded within that media. In this case, one of the things that Lev Manovich talks about within Instagram is this emerging types of image aesthetics that happen there. He creates these series of categories of different types of image types based on aesthetics. One of them is the images created by people with traditional disciplinary educations and things like composition aesthetics, like photographers and visual artists and architects. And the other one was this kind of design classification that he created or described which are kind of emerging aesthetics that sit outside what would be traditional disciplinary content for composition, but are things that have emerged through the pursuit of likes or kind of collective value on Instagram. So the types of aesthetic shots that that kind of generate more likes started to emerge or create these kind of collective directions. And he looks at different phenomena like duck facing and selfies as one of these kind of emergent phenomena. So what we did is we built this this machine, this platform of several different forms of neural networks that would constantly evolve over the course of a 3-month exhibition. And I don't get an opportunity very often to set up a machine that has that kind of length of duration of runtime. So it was a really interesting opportunity to start to look at how something that continuously evolves can begin to migrate away from my original intentions. So this machine has a social media account on Instagram called the Architectural Beast, and during the course of the show it would upload about 3 or 4 times a day new content, things like this. And the machine was composed of both a kind of image generating neural network as well as image classification network or analysis network, and a series of text generating functions built off of that image classifier to start to produce this kind of coherent user basically that we've designed for Instagram that could represent architectural ideas both through kind of image and aesthetic, but also through language and discourse. So this is kind of just an example of a walk through the machine's initial brain. This is early on in its learning. And the way the show worked is there were 11 invited artists into the installation, and each one of them contributed data sets from their portfolios. So we scraped their kind of past works, and we built up a data set for the machine to learn from at the opening of the exhibition. And it began to appropriate the features from these artists' work and start to produce these kind of compositions like what you see here. This is what's called a latent walk through the image production part of the network, where you are kind of going to different locations within the machine's, say, stored set of parameters or neurons, and generating images from them. And you kind of navigate around those regions, which is what gives it that kind of blending effect, is it tends to group images in the same regions that have similar features. But what we did was, beginning on the first day, every night at 9 p.m., the actual machine, in addition to posting Instagram, would also generate images during the exhibition. During the day, it would generate a new image about every 5 seconds. It could generate them faster, but it wasn't useful for the aesthetics of the installation for it to be generating any faster than that, because we also wanted to overlay the text and the content on top of that so that people had time to engage it. And it would do that during the open hours of the museum, but every night at 9 p.m. the machine would turn off its image generation functions and would go on the internet and start to source whatever the most popular architectural images were from social media on that day. And it would download those images and kind of fold them into its data set and relearn. So over the course of 3 months, it would move from learning 98 to 100% almost from the artists or the kind of institutionally selected and curated artists within the exhibition. By the end of the 3 months, it was 98% the content that was valued most highly on social media. So the grid on the left is the kind of types of compositions it was making within the first week, when it was primarily from the invited artists. But the thing on the right is what was made, or is the type of content it was making during the last week of its training for its exhibition. You can see that certain things like these pastoral landscapes and kind of medieval looking town centers started to become really dominant in the types of things it's producing, because when you looked on Flickr or Instagram and you were searching for architectural images, the kinds of photographs that got the most views were ones of kind of medieval town centers in Europe, or kind of open beautiful vistas on picturesque landscapes with little building follies in them. So slowly the machine started to begin to embody the aesthetics of the kind of collectively valued things on social media. This is just an example of the types of text it would generate. So this text was actually generated for this image in the upper left-hand corner. Generate like on this right-sided grid here, and it reads pretty well. It's total nonsense, but as far as like fake descriptions of images goes, it certainly seems like it's written by someone with architectural education. So unlike the image generation, though, the text generator didn't relearn every night. So it stayed with the kind of discourse that we initially trained it on, which was from architectural critics and theorists within the institution. So as the exhibition evolved, the images like moved further and further from the types of things that the text was describing, but the text was staying within the same kind of paradigm of referencing. This is the actual installation. The machine here on the left is the one that's actually running in real time. Each of the 11th artists had a kind of printed glass frame of a still image of their work. And then each one of them had a specifically generated set of content where the machine learned how to be more specifically like that artist than the others in addition to it. But the machine that was kind of continuously evolving is this one here, and it's the one that has the social media account. So this kind of project, I think, is a little bit of a weird one for us in that it was working with networks that were kind of purely autonomously about image generation and text generation. It wasn't like responsive to exterior content except for that kind of nightly engagement with social media. But I think it also begins to speak to strategies that we use a lot in the office, which is where we work a lot with kind of contingent systems. So in the case of that machine, like I was explaining, there's several levels of both generative and classification networks that are all feeding information into each other. And what we're doing is we're trying to build, through these contingent systems, these kind of collective or like well-performing wholes. When we get into the architecture, the way this works is we begin to fold in different types of data or different types of representation of architectural production, and also begin to create hybrid or stacks of intelligences which are performative within a certain scope of architectural design or production. So for example, here we have like a kind of, a plan input. So we're training a machine to understand planner information from precedents, but also doing things like this house that's shown on the right, which I'll talk a little bit more later, was for the site that we did a LiDAR scan of in the desert, which is what you see in the lower left-hand corner. So the machine that we use for generating the house was responding both to kind of disciplinary content from like architectural precedent, as well as three-dimensional like laser scan point cloud information of context and site. One of the things that's like critical when we're designing these contingent stacks of machines is to think about, as an author and as a designer, that data in a lot of ways is insignificant or has no inherent significance. It has let's say baggage or debris in it, but it's the kind of role of the designer or the architect to construct value out of that data. And that value can be mutable. Like the same piece of information could mean several different things depending on what types of mechanisms you construct on top of it to produce the kind of design content from it or the utility from it. So for example, this is just a series of integer representations of pixel values of actually like the texture map for the desert, to actually a very small corner of the texture map for the desert, which are essentially meaningless numbers to us. If we begin to feed them into RGB values that are normalized, it starts to become a data set that a neural network can read and start to overlay and construct image-based significance from for classification. But the same set of pixels might represent a desert to us, or it might represent a height field or orientations for planks or whatever. So like another exhibition that we did this past winter kind of based on that idea of like the kind of mutable value of these image-based numbers, was for this kind of rehashing of an older project. That was one of our first known projects about 5 years ago. That was looking at utilizing them to speculate on the transformation of landscapes as urban expansion occurred in the uninhabited areas. We were asked to like rebuild this this piece for the Pompidou Center this past winter. And what we did is we extended the stack a bit. So we were using it to both, starting from like an initial satellite image on the left, like using it to predict the kind of transformation of the landscape as global warming begins to pull back the glaciers in Greenland, how it might begin to be inhabited, then as a city master plan, how that could start to produce a skyline, how that skyline might represent a building plan. So we were kind of, we trained the machine to do appropriations of a kind of Noli map or Noli plan. And from that plan, we took that information and bifurcated it into in these kind of 3D printable models for a kind of sister exhibition that we had at the same time in Texas. So we had to make a bunch of 3D printed objects from the city plan. But also within the video, like they extrapolating a set of generic gray cubes from the planner information, then creating a kind of endlessly procedural cycle of those things moving vertically, and then translating those vertical transformations into exterior building facades, and then sampling individual moments within those exterior building facades to generate floor plans and interior perspectives of these apartments. And then we trained a network off of real estate websites like Compass and what's the other one? I can't remember what the other real estate website is, but to using a kind of data set that we scraped from Manhattan real estate postings, both generating from that interior perspective an expected value for the apartment. And it's Manhattan, so it's really expensive. But also little kind of realtor descriptive text on the right, being able to predict like how the machine might describe this apartment that it's selected. I'm not gonna like play this thing all the way through, but let's show the kind of transformations as it moves from desert to city. And from city to elevations, and from elevations to this kind of endless animation of exterior facades. And starting to overlay the interior perspectives of the apartments as the facade. So these perspectives line up with the facades as they're coming down through the, and we pulled out kind of individual ones. Let's see, we've got another one. And kind of valuation text and kind of automatic plan generations. The plans are like obviously not performative. Like for a piece like this, you know, we don't really force the plans to be like a kind of functional way. But the idea was to begin to stack all of these different ways of describing a city into a single piece using this kind of multitude of intelligences. So it starts to take on a kind of speculative utility for understanding how transformations to a landscape begin to embody things as far down as the kind of cost of apartments down the line. So with a project like that, and I think also with the beast, like one of the kind of central issues that we deal with as an office conceptually when working with feed-forward artificial intelligence like these, we work with both kind of feed-forward but also kind of semantic ones where you have to code the behaviors into them, is this problem of something called inductive stagnation, which Patricia Reed, I think, does a really good job of describing in a piece she wrote called Preparing for a Big World. But essentially the issue with it is that of inductive stagnation is the assumption that the inputs or the percepts or the priors of a situation are the truth of that situation. meaning that a machine won't search for solutions outside of the examples of solutions that it's already seen. And anytime like you have something that's like a feed-forward model, like these neural networks, they have a tendency to kind of represent existing design decisions, or to affect existing design decisions, but maybe at like kind of different grains of optimization. And I think like a lot of people kind of overstate maybe some of the generative capabilities by default within the machine because of this problem. They're excellent for automating the production of solutions that already exist. So to combat this, we've been specifically looking at the characteristics of things like the classifiers or the encoding layers to misunderstand or again construct value differently from precedents than we would as architects. So we spend a lot of time looking at using things like the Campo Marzio, which is the drawing on the right by Piranesi versus the Noli map, which is on the left. And specifically, like looking at this drawing on the right, through the lens of how a neural network might read it, in the sense that it's really only understanding the proportional relationships between mass and void, or threshold to space, as a pure graphical operation, and stripping it of any of its architectural and historical significance. And based on how we frame in what it's learning from that map, we also are constraining how it understands, hierarchically how these thresholds are working within a piece of architecture. So by zooming in on specific threshold moments within its training, the machine never really learns how to understand things like biaxial symmetry, or the kind of layering that we see in the colonnades and in arches and bolts and things within this drawing. And that kind of operation has led us to exploration over a series of projects. It's pretty central to the office of like working to define an architecture through its interface elements. And sometimes the interface elements are kind of digital, like scanning and surveillance operations, but other times it's more traditional architectural interfaces of things like doors and windows, gates, colonnades. Thresholds are a form of interface in that they kind of delineate one space from the other, and they serve as the mediator between those spaces. Sometimes they're between interior and exterior, other times within different scales or states of interiority. So that kind of plan exploration started out first with this project, which was purely a speculative one for a kind of skyscraper design through this logic. It's difficult to see in these drawings, I realize now. But there's a series of kind of dense colonnades that work with the more pier-like objects to generate the kind of subdivisions of space within each floor. It pretty clearly, like, this doesn't actually function as a skyscraper, but it was really kind of a first stab at trying to automate the production of some of these spaces where you have to rely on different criteria for evaluating their organizational success than a kind of typical partie or diagram. We extrapolated the same algorithms for an installation we did here at SciArc, where we automated the kind of design and the kind of panel production and drawing set production of this installation out of wood timbers, feeding it a kind of feeding it the space as a voxel field, and automating production of the plan, automating the production of the timber patterns and the locations of the screens within them to create this this was supposed to be a kind of model idea of utilizing these piers to frame in a domestically scaled space, like something around a living room size within the gallery, and then embedding it with a series of web cameras and 3D scanners to track human movement and turn the occupants of the space into the kind of ornamentation in some cases, or to drive like user-based media effects. Like, so in the case of the back wall, like every up to 6 occupants get their own kind of perspectival lookout into the city that's generated from like horizontal drone paths. And then the other screens did things like extracted your facial features and tried to turn them into a kind of graphic pattern, basically as a play on ideas of like narcissism, of wallpapering the interior of someone's space with mutations of their own image. Kind of variations on that project. So in specific to the kind of more planar-oriented aspects of it and some of the structural aspects that we took from that, we were commissioned to do a house in the desert near here in kind of California. The project's kind of indefinitely on hold now. But this version of the project I'm quite fond of. This is the site. And again, we're like looking at referencing some of the kind of Mises projects in terms of how we're thinking about the orientation. But one thing that we really wanted to do was shatter some of the relationships between kind of grid and partition. And again, like really focus on how you can assemble a building footprint or floor plan through only the relationships of these threshold features to each other, in an effort to try to produce an architecture which couldn't be represented through a partie or diagram and plan for its program orientation. And some aspects of it were successful. This is probably the craziest version of the plan. There's some very difficult to get into closets and things in this. And at certain points, there's another version of this plan which has pocket doors, which make it a little bit too legible in terms of how the spaces are divided. But essentially, the project can also be read, or as part of the brief, it had to be able to be transformed between either one large, like 3,000 square foot or 300 square meter kind of vacation spot, or 3 smaller Airbnb units, which could be inhabited. So depending on how some of the dynamic partitions within the interior were arranged within the static ones, which are shown in this plan, it could be configured. But what we liked about it was that in plan, it seemed like a completely illegible kind of accumulation of partitions and forms. But in perspective, it becomes immediately legible about like where one space begins and where another starts, or it's implied through this kind of assemblage or density of these material elements. The structure of the house was meant to be, these are all kind of early concept renders without getting into the kind of detailing of it. Obviously, there's like flying parts of walls and stuff. So this was not the kind of version towards constructability, but the idea would be to start to assemble these things out of autonomously produce like robotic CLT panels or cross-laminated timber panels, where some of the patterns here represent the directionality of laminates or timbers within these kind of customized composite structures. Here's some examples, some of the, both like translating the initial data of the form into pure voxels, and then also then how that translated into directions for timber layout. And we did a bunch of like little tests of the algorithm with like using the robot to build tiny models and 3D printing to test tool paths from the patterns. And we utilized the same process in the kind of final project in this series to build up the structural system for our proposal for the Talon pavilion, which Sumin won. She beat us, because hers was much cooler. But we were kind of obsessed with the house. Like, it had been effectively canceled at that point for a number of reasons out of our control. We really wanted to begin to pursue in the office, Yasushi Yoshida and my partner, how we could bring something like that into existence. So we did a kind of deep dive, both in terms of again, like studying these kind of non-diagram or non-totalistic spatial organizations, but also the details for how to begin to assemble some of these panels. So we did a bunch of explorations in different lamination patterns, how different types of architecture in the space could be represented through different timber assemblies. So some of the kind of more open voxel structure, like in the installation at SciArc, and others is kind of flatter timber laminations, like what we were planning for the house. And we went back and forth utilizing study models again although these were kind of manually constructed to explore how we could build in details to allow for things like auto centering of panels as you put them in place. Because when you have a plan like this, you're relying on a lot of things in order to orient the construction of it. Like things like column grids are extremely useful when you have like a human contractor who needs to be able to lay out curbs and foundations and walls and things like that within a space. So what we were looking at within the project is how we could begin to embed that kind of information into some of the panels so that as you brought them out on site, they would instruct you about how to begin to assemble them, and they could really only like fit together in a specific way. So trying to make it unnecessary for those sorts of guiding features. And in some ways, like I think the project is, we were happy with the way the plan worked out, but for our kind of ambition is to produce this diagram-free construction, or this kind of illegible afigural product. The hierarchy of the elevation is really, we're very unhappy with that at the moment, in the sense it's clearly legible that there's a kind of roof slab and a series of walls. So a lot of the kind of threshold-based or interface-based readings that in the plan, which is the only way to understand that plan, don't really apply to the elevation because it's so clearly legible in terms of its tectonic hierarchies of it. There's some different shots about how like the stairs also working with the walls to produce different spaces, and how the different timber patterns occur based on the specific connections that are happening in those areas, kind of stresses or loads within them. And then we build up a series of software in the production of this also for the robot. I teach a series of seminars at SciArc. Our robot facility features these kind of smaller scale robots which can only do kind of lightweight fabrication, although we've received funding and are beginning the construction of a new facility which will have a robot which will allow us to produce architectural scale panels and platforms like in the case of the pavilion. But what we do with the students is that we kind of break off different parts of these AI packages. So in this case, we're specifically using the kind of 3D form generation neural networks and the panelization scripts, some simplified versions of the panelization scripts that we work with, and have the students begin to explore how they can take kind of volumetric forms and rethink them as panel constructions. There's a lot of human in this process, maybe a little bit too much human. But these are some kind of the outputs from that. So some of the structures that they produce using some of those software packages that we developed. And I think that's it, Sumi. I started talking fast because my voice is leaving me.
Yeah, thank you so much. Casey is not very health condition is not very good, but like you managed to really talk for. Thank you for giving us this lecture. Yeah, despite the health condition. Thank you very much. Can we have everybody turn on your video back and being able to have a bit of discussion session?
Can I get some water really quick?
Yeah.
Like 30 seconds? Okay.
Sure.
Right back.
Great. So, yeah, in the meantime, I know Casey for a long time. We are also very good friends. We are colleagues here in SciArc as well. But his work is, I think, it's really has been very much like dedicated in like really critically looking at technology, the development of the AI and technology that into design thinking and design thinking methodologies. So especially from very early on, he was really invested in the artificial intelligence, machine learning. Although nowadays everybody's doing that, but I know Casey has been doing this for quite some time, and he has like being able to accumulate some really good sets of work as examples, and I hope it was very inspirational for you guys. And yeah, hope if you have any questions, please shout it out, or if you want to put it on the chat, I can read it for you as well. But feel free to unmute yourself and yeah, jump into discussion and ask questions. Can be just comments as well. Or any thoughts?
Okay. Okay.
Okay, we have Doruk first, and then next one, Chokun.
I wanted to ask about this last project you showed us. I saw people doing it on the building, but I couldn't quite understand how like the thinking was behind it for the you said panel systems. Is that correct?
Which one?
Which one? Oh, for the robot stuff?
Well, like what exactly was the intention with the like I get that like they were supposed to be built by the robot and not the humans, I suppose.
Well, no, I mean the robots were to build panels, and the panels should be like so this is like scaling down like techniques that we're going to be using for prefab housing here as we get the kind of new facility up and running. So the idea is that the panels should have built-in details that allow someone on site to erect them faster. So they're kind of like a flat pack panel.
Okay.
Thank you. Chokun, you had a question?
Hello. Okay. Thank you for the presentation. I think it's very inspiring. There are a lot of interesting projects, but something that I kind of wonder, like for example, do you maybe have some of the project that would be more approach toward the commercial approach, or maybe some of the design aspect that you kind of put towards the commercial project? Or I kind of wonder like how to what extent do we have a part toward that category? I just wonder, is there any example where you kind of integrate some of the thoughts toward the commercial projects? I don't know.
Like am I like
yeah.
What?
No, I think as I understood, whether your project, how in what extent it can be applied to like more commercial kind of architectural project, like more traditional probably, or like
I don't do traditional architecture.
Chokun, was that your what do you mean?
Well, look, I mean, like these kind of tools are great for optimization, and certainly in the past I've consulted on doing stuff like that, but I have zero interest in like basically, I think the point of the work I'm doing is to try to uncover what new aesthetics or new potentials there are for the architecture within these territories, rather than just engaging with the kind of known or already accepted. I mean, certainly when I have to pay the bills, I can do that, but there's no value in that. That's the default.
Yeah, I think the value of this work is it might look quite research-based and quite conceptual, but it's also a lot of thinking can be pushed further in academic projects, and I think with like small practices like cases or mine as well, like we don't really get like really big projects too much, and it might I think it might look like why not these ideas are actually applied immediately to a larger commercial projects, and maybe that if that's a question, I think it might be saying that it's not a case's interest, but I think it's these ideas behind can be easily applied, but actually in a larger, like most of the commercial architectural projects, there are a lot of constraints to be very experimental. So that's why most of the very experimental ideas are mostly applied in smaller projects to begin with, I think. but there are also a lot of steps, and this will be accumulated to become more applicable larger projects, I believe, in the future. Yeah.
Yes.
Hi, I have a question.
Yeah.
Yeah, absolutely great work, Casey. Thank you so much for your lecture. Very interesting to see how the patterns or the plans were developed by AI. But I want to know how we can perhaps be able to reduce the man hours on the fabrication, because that accounts to nearly 30% of total construction budget. And it's really complex and difficult to explain to uneducated labor. Besides, do you think it would be easier to manually model that rather than have AI generate it for you, because it's much easier to sort of use the same geometry and repeat it again in variations?
So, like one of the things that like this software that we're looking at, I mean, look, like that's what this stuff is good for, is automating and reducing labor. Like that's what it, like out of the box, like if you just use it as it should be used, that's what it does. Like if you're looking, like any feed forward system is basically training on like the existing way that you solve a solution. So, we can utilize it for both the kind of like white collar man hours of doing things like feasibility studies, like office floor plan layouts, things like that. Or in terms of the assembly, like yes, like you can assemble these forms like through automation, which is what we're working on with the software platform with the robots. So no matter what you do, it's always lower cost to do the same thing over and over again. Like even within the case of like robots laying up a panel template, the having to change the pattern each time introduces risks and different types of issues within the assembly line. The idea of a platform like this would be to reduce that kind of consequence on top of the assembly platform for like other benefits. So being able to make more eccentric panels or build in things that like like within CLT, for example, you basically make all of the panels, and if you want to put like an aperture in it, you have to mill it out, which is time consuming and wasteful. So with the kind of platform we're building here, one of the things that we have within it is automatically sizing the timbers and putting them into the pattern in the panel layout is what we're trying to do to kind of cut that part out of it and kind of reduce the cost of producing a custom panel each time. So there's performative benefit to it like that. That's less of an architectural issue and more of a kind of building industry issue. But it is part of the aspect of what we're looking at. Particularly when it comes to housing, like one of the applications that we want to take this platform into is for rapid housing production to begin to deal with some issues here in LA. So when we get the new facility up, that's the first project we're looking at, is translating things like the structural system that we began exploring with the pavilion and the desert house to smaller scale housing units that could be essentially flat packed and shipped out to the site and tilted up quickly. But still like having enough customization into them that allow for variation and difference.
Sure, thank you. Thanks.
Cool. Yeah, I have another like not question, but I particularly are really interested in that image that you show after the architectural beast, where you compare these two sets of images. One is from like artists, and another one is trained by social media, and like it kind of represents what general public thinks about what good architecture is. Yeah, so I thought that image was quite provoking and quite kind of shocking as well, and interesting in a way to really using kind of this AI technology to really try to understand certain phenomena in terms of like architectural aesthetics. Yeah, I don't know if everybody had like really understood that project, but I thought like it's quite provoking. It's a comment.
Oh, okay, thanks.
Yeah.
I mean, look, I think that you know, like one concern I take away from the sorts of questions you guys have, and this is just something to consider, is your role as a designer. A lot of the stuff that happens within architecture is driven by, or is symptomatic from the way the system operates, right? And if you want to begin to take agency over it, you have to kind of, you know, I think question some of the trajectories, because again, these systems have huge momentum behind them, these forms of artificial intelligence, to basically ossify pre-existing design solutions, right? And I think that what you want to do is maybe take a step back to consider less about how to optimize the existing ideas about what architecture should be, and reconsider what architecture should be for the contemporary context. I think like a good example is the kind of micro housing that we're seeing, and is kind of fitting it's fitting a market that has emerged in real estate. But do we want to view the micro housing typology as something that's a desirable solution, or something that's symptomatic of a system that's being reduced? And can we find a solution other than that is maybe more desirable or relevant to a contemporary cultural context than simply kind of automating or refining the existing one within the pressures of the market? So just something to consider. I think that there's a lot of work in AI on automation, and it makes sense, but you also need to be cognizant of the fact that you're ossifying like pre-existing concepts of relevance and value. Okay. Okay. Sorry, I've got a migraine and an ear infection, so I'm on like a bunch of painkillers. I'm not at 100% today.
No problem. Yeah, really appreciate.
Okay.
Yeah. Yeah. So, if we don't have any more questions, so Casey, what is the best way for us to follow up your work? Instagram or website? If you can guide us to follow up your work.
I guess Instagram for now. Like Instagram, I tend to put a lot of trash on, just like stuff that we're working on. But like normally I would say website, but I took down my old office's website before I finished putting up my new office's website, so there is no website. SciArc's website, right? You should all follow SciArc.
Great. And also, do you want to talk a little bit about the program that you are directing?
Yeah, so the program is 3-semester, 1-year Masters of Science, and it's in architectural technology. The aim of the project, of the program, is that every student that comes through produces a platform, and is really looking at software platforms as the new kind of territory for design and architectural production. We have like a great group of faculty that are teaching in it, including Sumi, who's going to be looking at platforms for fabrication and advanced materials, as well as Benjamin Bratton, who is a theorist on like different issues of kind of platform production. We'll be looking at kind of platforms in the sense of like design tools, platforms as the city or the building as platforms. So we'll talk about like smart cities like Sidewalk Labs, or what's the one in Korea? Songdo?
Songdo, yeah.
Songdo, yeah. And then also platforms for governance, like how those are all kind of things, new territories the architecture has to participate in. So we're working with different research grants with private institutions on larger research projects, but each student will carve out their own research project within the kind of overarching umbrella of platform development.
Cool. Yeah, so it's a 1-year master's course, right?
Yeah, 3 semesters.
Yeah.
Yeah, so it's August to August.
Yeah, I think I also know like this kind of like computational courses, urban design or architecture design courses in different schools, including AA and Bartlett. But I think this one is quite unique, that is really trying to like educate and nurture a entrepreneur of as an architect. So it's like not only about the project, developing certain projects, but really about like nurturing the person. I think for that I was quite impressed by the philosophy of education in SciArc, and that's quite different from other schools. So yeah.
Yeah, I mean,
That's my
yeah, that's the key thing for us is we also will be having in people, particularly in the spring semester, that are coming from venture capitalism to talk about kind of business strategy, business plan development for each of the students. LA is kind of the best place on the planet to do that right now, which is where we are. We're going to have great facilities. Like we're going to, I mean, it's on hold for a little bit. We had to stop construction because we're in quarantine, but not quarantine. We're not quarantined. We're in a, what's it called? Safe at home. Recommended you stay at home. But we're gonna have a new robot facility. We have new artificial intelligence servers, GPU servers for doing high-end research, and we have a series of projects lined up also that the students from this program have first dibs at being research assistant positions. And for one of you guys that was really interested in automating construction, like that's one of the research projects we'll be doing, is actually working with a timber manufacturer here in the US to produce automated panel laminations, which maybe also is commercial. We might make money one day.
yeah. Thank you very much, Casey. Yeah, joining us with like very harsh condition. All right. I hope everybody enjoyed the lecture, and yeah, hope you can follow up his work on his Instagram, which I will also post it on the YouTube channel. Okay. Thank you very much, Casey. Thank you. See you soon. End stream. Okay. So for everybody